In this video, we're going to be talking about the definition of probability. So let's go ahead and begin by talking about what is probability. Well, there are three different approaches to probability. The classical approach. So when the outcomes in a sample space are equally likely, the probability of an event, E, denoted by P of E, is the ratio of the number of outcomes that are favorable to E to the total number of outcomes in the sample space. So here we'd have P of E equals favorable outcomes divided by total outcomes. So some examples of this would be flipping a coin, rolling a dice, things like that. Now on some football teams, the honor of calling the toss at the beginning of the football game is determined by random selection. So suppose this week a member of the 11-player offensive team will be selected to call the toss. There are 5 interior linemen on the offensive team. If event L is defined as the event that an interior lineman is selected to call the toss, what is the probability of L? So our probability of L would be the 5 interior linemen out of the 11 offensive team members. Consider an archer shooting arrows at a target. The probability of getting a bullseye should be the ratio of the area of the inner circle to the area of the entire target. Well, what if a very experienced archer were shooting the arrows? Would the probability of a bullseye still be the same? The classical approach doesn't work for every situation. Consider flipping a coin and recording the relative frequency of heads. When the number of coin flips is small, there's a lot of variability in the relative frequency of the heads, as shown in the graph. But as we get more and more flips, you'll notice that that relative frequency begins to stabilize. What do you notice in the graph at the right? Do you see the large variability? Do you see the stabilization? What else do you notice? Consider flipping a coin and recording the relative frequency of heads. Let's keep going with that. The graph at the right shows the relative frequency when the coin is flipped a large number of times. What do you notice in this graph at the right? Notice that as the number of tosses increases, we get closer and closer and closer to that 50% or that 0.5. This brings us to our law of large numbers. As the number of repetitions of a chance experiment increase, the chance of the relative frequency of the occurrence for an event will differ from the true probability by more than any small number approaches 0. In other words, after a large number of trials, the relative frequency approaches the true probability. Notice how the relative frequency of heads approaches 1/2 the larger the number of trials gets. There's also the relative frequency approach. The probability of event E, denoted by P of E, is defined to be the value approached by the relative frequency of occurrence of E in a very long series of trials of a chance experiment. Thus, if the number of trials is quite large, then we'll have P of E is approximately the number of times E occurs divided by the number of trials. We also have the subjective approach. Probability can be interpreted as a personal measure of the strength of belief that a particular outcome will occur. Here's an example. So an airline passenger may report that her probability of being placed on standby, meaning denied a seat due to overbooking, is 0.1. She arrived at this through personal experience and observation of events. The problem with a subjective approach is that different people could assign different probabilities to the same outcome based on their subjective viewpoints. Probability statements are frequently encountered in newspapers and magazines and, of course, in textbooks. what is the basis for these probability statements? Well, in most cases, research allows reasonable estimates based on observation and analysis. And in general, if a probability is stated, it's based on one of the three approaches that we just talked about: the classical approach, the subjective approach, and the relative frequency approach. When you see probabilities in published sources, you should consider how the probabilities were produced. Be particularly cautious in the case of subjective probabilities.